Great. Well, good morning, everybody. And like the other speakers, I'd like to congratulate TransGrid on this initiative of airing the problem or having this consultation at the problem definition stage rather than this is the solution. And I think it's a genuine step towards greater transparency in the planning of this important infrastructure, which is the network. And on that basis, I think that Stephen's warm and fuzzy feeling is justified. What I want to talk about today is reliability standards, and reliability is really about what happens if you get it wrong. If you don't have a reliable power system, what does that mean, and how do you make sure that you are investing appropriately? So I'll talk a little bit about what a reliability standard is. I'll talk about some practical aspects. I'll describe TransGrid's actual reliability standard as pertains to the urban area. Brief discussion on international practice, and then maybe some points about if you want to consider changing the reliability standard. It's traditional when you're talking about reliability to trot out an old war story of some blackout or other, and I'm not going to break that tradition. In Auckland, you all know about the really very bad incident that they had in 1996 or 1998, I think, where they had 4 cables fail and they had the CBD without power for about 50-something days. It was a really serious event. But I want to talk about something which is a little bit more recent than that, and one that I had, I wouldn't say a role in, but I was certainly involved in it. And that was an outage of at one of the, or it was the only substation at the time that was supplying power to the Auckland area. And what happened there was a D-shackle, which is about this big, cost about $3. It broke, and an earth wire fell down over the substation and blacked out. All that dark stuff there is the parts of Auckland that were blacked out. There's one. Where's the pointer?
It's just that red one there. The red.
Oh, the red one, right.
Yep.
There was one line that stayed intact, and that supplied north of Auckland, and they were very happy about that. That's the rich part of town. But this outage lasted about 5 hours, which is quite quick in terms of power outages. But all the things that were mentioned previously about, the economic impacts of having an outage like that, they were all very evident here. The CBD was basically shut down. Businesses shut down. They couldn't transact using their FPOS systems. The mobile phone system worked for a while until the emergency batteries ran down. So it was a very significant event. About 1,000 megawatts of load was unsupplied during that event. So the next thing that happened, of course, was you had the political response, the opposition. Doesn't matter who's in opposition, but the opposition came out and said this was all preventable, it was the government's fault. That's the reality of life. But look, the point is blackouts in cities are big news. They have huge effects, and businesses can't operate, so you've got a financial effect and you've got an effect on amenity as well. And generally, it doesn't take long for chaos to set in. So where are we going with this? Whenever there's a blackout, power companies like Ausgrid and TransGrid will investigate and see what happened in that particular blackout and see whether they have the same level of exposure. So there's a great deal of interest. Reliability of urban areas is something that receives a lot of attention. And what we're talking about today, what I'm talking about today, is a mechanism that policymakers put in place to try and avoid having that style of incident. So what is a reliability standard? Well, it's a policy decision on risk and uncertainty. It's what policymakers say, what they define, and they give to people like Ausgrid and TransGrid to say, you must deliver at least to this standard. A reliability standard does not guarantee an interruption-free supply. It just reduces the probability of it occurring. The deshackle, nobody's reliability standard would have fixed that. So it is not a guarantee that you're not going to have interruptions. But a lot of people blame reliability standards for overinvestment, and that's a point that I disagree with. I don't believe that a reliability standard causes on its own overinvestment. What the reliability standard does do is it creates a trigger point where action is required. It basically creates a trigger point that Ausgrid and TransGrid then have to say, look, we're forecasting that in such and such a year we are not going to be able to satisfy our reliability standard. We need to do something. What you do is different to, it's not dictated by the reliability standard. It's a trigger which says you must do something. What you do needs to be decided based on all the information that you've heard in the room today. There's a whole lot of different options. You can build network, you can do demand-side management, you can distributed generation. You can consider all of those things in terms of what you do in response to having met the trigger point. So the requirement to do something is delivered by the reliability standard. What you do is something that's driven by economics. This is basically what we're talking about, and it's like economists. When economists describe anything at all to do with economic theory, they have a supply and demand curve. This is the reliability equivalent of that. What we have here is a cost of reliability, which is the cost of providing infrastructure. It's the cost of building cables, substations, transformers, etc. And on this side, we've got something which I've called the cost of unreliability, which is what happens if you do have an interruption, what are the costs involved? So if you interrupt, in the case of Auckland, if you interrupt half of Auckland for 5 hours, what does that actually cost the economy of the country? Very easy to draw, not very easy to actually quantify. And to make things a little bit more complicated, is it's not necessarily the same in different parts of the network. So if you go out into rural New South Wales, the cost of delivering the infrastructure might be quite different to the cost of delivering infrastructure into a CBD environment. Simple example, overhead line is much cheaper than cables. You can't put overhead lines in the CBD environment. You have to use cables. So different parts of the network actually have different cost curves like this. So it's not a trivial exercise that we're going through. These things are quite complex to work out. But the objective of your reliability standard is to try and get the sweet point over here, where the cost of delivering your infrastructure matches the cost of unreliability. If you go onto that side of that sweet point, it means that you're delivering more reliability than your actual cost of unreliability. So you're delivering a system that is more reliable than people actually value. And the same thing happens over here. If you underinvest, if you choose a reliability standard over here, your cost of infrastructure is low, but your cost of unreliability is high. Okay, so that's a sort of a fairly simple explanation of what you're trying to achieve. What policymakers are trying to achieve is to get somewhere round about here, so that the amount of investment is actually justified by the value that people place on the supply of electricity. We'll probably come back to that a couple of times. What is the standard in New South Wales? Well, as I said, it varies in different places. But in the main grid of New South Wales, so we're talking about the sort of the backbone, not the supply to the urban area, The standard is basically what we refer to as an N-1. And what we mean by N-1 is we've got a power system, it's got a whole lot of different components, and we say there are N components in that power system. N-1 means that you can tolerate the loss of any one of those components without losing supply, so without compromising the reliability of supply. So that's a basic reliability criterion for the rest of the New South Wales system. But for the inner city area, there's a higher level of reliability, and the reason for that is, going back to the cost curves, is that the value of energy in the CBD, the consequences of not having a reliable supply in the CBD are much higher. So you would expect there's more investment to make sure that you don't suffer those high costs of unreliability. So the standard that is applied, and it's not just a TransGrid standard or an Ausgrid standard, it applies to both of them, sorry. What's happened there? Back? That should be forward.
Back.
Back.
Yes.
Yes, all right. Finally, I've got the...
We're probably going about 5 or 7 minutes at the most.
Okay. All right, so what the reliability standard is that you can lose one of these cables, one of the high voltage cables, or and one of the 132 kV cables. So this is the policy decision that has come out. It says, TransGrid, Ausgrid, you must design your power system so that you can tolerate that level of outage. There's a second part to it which says you've got to be able to lose a bus bar. Now, a bus bar is a common connection where you have a number of circuits connected. Very, very unlikely that you have a fault on a bus bar, but I just told you about Auckland, that was a fault on a bus bar. But there was a fault in the case of Auckland, that wire that fell from the shackle fell across 2 bus bars, so you had 2 bus bar faults. They do happen, and they're very serious. What I've illustrated there with the little green circles is that if you had a fault on this bus bar, the purple star, you would lose 6 circuits. Okay, so that's a very, very high consequence. So that's the reliability standard that you have here in New South Wales. 2 parts. One is you can lose a 330 kV cable and a 132 kV cable, or you can tolerate the loss of a bus bar, which will lead to multiple cable or feeder losses. Just summarising. The reliability standard is a trigger. It indicates that action is required. Does not say what has to be done. And I think that what we're seeing from Ausgrid and TransGrid is that they are looking at the economic merit of the various options, and they will choose something that will allow them to meet that reliability standard. The reliability is a trade-off between infrastructure cost and the cost of interruptions. If you reduce the reliability standard, which is an option for this particular problem, you can say, well, maybe we don't value reliability as much as we thought. We can lower our expectations. If you do reduce it, it will decrease the infrastructure cost. It will either remove the need for infrastructure or defer the need to invest. But you can expect that it will increase unreliability costs. The Sydney reliability standard is similar to international practice. Most large capital cities around the world have an N-2 criterion, which means that they can lose any 2 items of plant in the power system, in the urban power system, without compromising reliability. So it's a little bit stricter. The international practice tends to be a little bit stricter than the TransGrid standard. And I think that in the rest of Australia, if you look at the other capital cities, the Sydney standard is similar to Brisbane, Adelaide, and I think even Melbourne. I'm not sure about Melbourne. So what we can see with the Sydney reliability standard is that it does have some pragmatic elements in there to avoid overinvestment. If it was an N-2, for example, you'd see those 2 330 kV cables that exist already. If you had both of those out at the same time, that would immediately trigger more investment. So it is an option to reduce your reliability standard, but going back to that curve. It's going to be a trade-off between unreliability and the cost of the infrastructure. It's not an easy task to do, but it is possible to at least estimate it.